To see more examples regarding how the mirror will behave in a viral environment, okay, let's do a slightly different exercise here. So here we have this asset EOY defined as the following, and the partition in this index function is based on stock symbol and year. Okay, so let's define a new mirror, okay, which is slightly different from the current mirror. So I'm going to again copy this, and I'm going to define new mirror inside this under this example table. So this mirror, I'm going to paste the code there. However, the only change I'm going to make is, instead of kind of telling Power BI that our data table is going to be partitioned by stock symbol and year, I'm only going to partition it by stock symbol. So each partition is basically determined by stock symbol with no regard to the year. Okay, so all the data related to a certain stock symbol is going to be one partition. Okay, all the data related to Apple is going to be a partition. All the data related to another stock, say Ford, is going to be another partition. Okay, so that's how this mirror is going to be defined. Okay, the other part of code is the same. We still tell Power BI this table, this example table, okay, is identified. Each observation in that table is identified by a stock symbol and a date. That's true. Okay, then within, okay, let's take a look at this. Okay, that's an example table we're talking about here. Okay, so each observation is identified by stock symbol and particular date. Okay, then the match by, well, that's a match by. Okay, match by tells how each observation is identified in this table. It's identified by a combination of stock symbol and date. Then this partition by basically tells Power BI how this table, example table, is partitioned into different groups. So now the partition is based on symbol. So each partition is basically a block of data related to a certain stock. Okay, so this is one partition. This is going to be another partition. Okay, this is going to be a partition regarding Ford, and lastly we have partition regarding IBM. Okay, so within each partition, this order by tells Power BI within each partition the observations are going to be ordered by date ascendingly. Okay, apparently here we have within each partition the dates being ordered ascendingly. So that's going to be the data structure this index function is telling to work with. Okay, I'm sorry, this is the data structure on which the index function is told to work on. Okay, so that's a thing we need to pay attention. So now, because that's a different mirror, so I'll call it M2. Okay, so this is going to be a different mirror, and I'm going to get M2 also inside this matrix. Then you can see the slight difference. Okay, the difference is not really kind of significant, but if you pay attention, here's the difference. Okay, for Ford, for the first mirror it returns 25, for the second mirror it returns 27. Okay, for IBM again, the first mirror returns 11, the second mirror returns 17. Okay, regarding particular years, however, you don't see a difference between those two mirrors. They just return the same value for all the different years. Okay, so now let's first look at how the second mirror actually works. So for example, if we're looking at this row, Apple year 2022, how does this mirror return a value of 33? So let's take a look. So Apple year 2022 is gonna be the future context, which means we're going to look at those 4 rows. Okay, then this mirror is gonna return the last row. Again, -1 means the last row in the current partition. Okay, after the future contexts are being applied. Okay, you're only going to work on data after the future. Okay, you're only going to work on the filtered out data, which is this 4 blocks. So index function only have access to this 4 rows of data. Okay, it's only going to work on this 4 rows. So this 4 rows, can this 4 rows determine what's the current partition? Let's take a look. The current partition, the partition is determined by just stock symbol. Okay, so all those 4 rows are related to Apple. So that's gonna be easy to determine what's the current partition. It's gonna be the Apple partition. All right. So the current partition is basically all the 4 rows related to Apple. Okay, there's no other stocks involved, so that's the only partition available now. It's related to Apple. Okay, so within this partition, index function is gonna return the last row of this partition, which is row 5. Okay, row 5 has an asset value 33, so that's why you see 33 here. Okay, now if we're moving to this row, we're looking at Apple in year 2023. Then what's gonna happen? Again, once you are moving to this row, this new filter context is going to be applied to the original data, the example table data set. Okay, so now we are only working on the filtered data, which is those 4 rows, Apple year 2023. Okay, so those 4 rows are the only data available to the index function now. Okay, index function is going to take a look at these 4 rows and determine what's the current partition. What's the current partition? Again, all those 4 rows are related to Apple, and the partition is determined by stock symbol only. Okay, so the current partition is basically just Apple. All right, Apple partition is here, and the index function is going to take the very last row out of this current partition, which is row 9. Okay, so lastly, the min x function is going to take a look at the last row, row 9, and take the value of assets from that row. So that's gonna be assets value is 32 on row 9. So 32 is gonna be returned. That's why you see a 32 here. Okay. So how about Ford? Basically the same idea. All right. So for Ford, again for year 2024, you are going to look at just year 2024 is here. Okay, it's gonna look at this 4 rows. That's the filtered data. After applying the filter context, that's the only data left for the index function to work on. All right. So apparently these 4 rows can determine what's the current partition. All those 4 rows are related to Ford, so basically the current partition is the Ford partition. There's no other stock symbols involved in the filtered data. So Ford is the only current partition available. So within the current partition, we're going to take the very last row, which is row 13, and then the min x function is going to scan this row 13 and take the minimum value of assets, which is basically 25 itself. Okay, so that's why you see here for year 2024, this mirror returns on the value of 25. Okay, so now let's look at this row related to Ford. Okay, this row. Mirror 2 returns a number 27, and mirror 1 returns a number of 25. So why the difference? Okay, so once we're focusing on this row is going to be the filter context we need to apply to the data. Okay, so now we're only looking at data related to Ford only. All right, so let's go back. So basically, after using the filter context, that's all the data remaining. Okay, this 8 rows related to Ford is the data the index function is going to work on. So now, how to determine the current partition? The current partition, again, is determined by stock symbol only. So all the 4 rows relates to one partition, the Ford partition. Okay, I'm sorry, all the 8 rows. Okay, all the 8 rows is within one single partition related to Ford. So this entire 8 rows are the current partition we're working on. So index function is going to work on the current partition, which contains all these 8 rows, and then take the very last row out of this current partition, which is going to be row 17. All right. So here, this variable last row is only going to take row 17 out of this block of 8 rows. Then the min x function is going to work on this last row, this very last row, which is row 17, and calculate or scan the value for assets, which is 27. Okay, and because there's just one single asset value here, there's no multiple rows, just one single row here, and there's only one value for assets, 27. So the minimum is going to be the self. So the minimum 27 is going to be returned. That's why you see a 27 here. Okay. Now let's go back to the mirror 1. Why mirror 1 returned 25 instead of 27? That's because mirror 1, look at mirror 1's definition. Mirror 1, you partition the data by a combination of symbol and year. Alright? So in this case, if you're looking at this row related to Ford, as we learned before, we're still looking at these A rows. Okay? But within this A rows, there's two partitions, not just one partition. Okay? Because we have one partition related to Ford in year 2024, the other partition related to Ford in year 2025. Because in the first mirror, partition is determined by a combination of stock symbol and year. So because here we have two different combinations, Ford 2024 and Ford 2025, right? So we have two different partitions. Means this block of rows has two partitions. So in this case, the index function again is going to return the very last row of the current partition, but because the current partition actually involves two partitions, which by all means is not the ideal situation. Okay, usually you don't want to work with a situation where the current partition is actually related to multiple partitions, not just single partition. Okay, but anyway, now we have two so-called current partitions, and the index function is going to return the last row for each partition. So that means the index function is going to return, first of all, for the first partition, it's going to return this row, okay, row 13. For the second partition, it's going to return row 17. And then the min x function is going to scan these two rows. By the way, these two rows are stored in this variable called last row. Okay, it's going to scan these two rows and calculate the value for this data fields across these two rows. Okay, so which is going to be 25 and 27. Then the min x function is going to take the minimum value for this assets field across these two rows. So 25, 27, of course, the minimum is going to be 25. So that's why you see here the mirror returns a 25.